Alright, part 3 of our final exam review brings us finally to everyone's favorite subject, chemistry. Alright, looking at our study guide here, let's see, we start with vocab. 3 important vocab words to start you off: solid, liquid, and gas. So, what are those things? Solid. Particles are close together in a solid. They vibrate on the spot, just like you see in this picture here. The particles are very close together and they're vibrating really quickly together and in spot. So what you want to remember for a solid, the particles are close together and they're in a fixed shape. The shape is not going to change. Next review item is liquid. The particles in a liquid are in a random order and they move around each other very slowly. A liquid takes the shape of a container and they tend to stick to the container. So remember, for a liquid, particles are close together and they're always moving. Particles are moving and close together. That's a liquid. See, they're close, but they're moving. They're moving around each other. Remember that in a liquid, the liquid will take the shape of the container, just like a gas. A liquid will take the shape of the container and it tends to stick to the container, and that's why things get wet. Next up is gas. The particles are not close, they're far apart, they're arranged randomly, and they move very quickly in all directions, like this. Gas particles are far apart and they move quickly everywhere. Gas particles also take the shape of their container. So as you see in this picture, the particles are far apart and they're quickly moving around. And they take the shape of whatever container they're in. For example, the gas in this balloon here is in the shape of a balloon. The gas in this room I'm in, that gas is shaped like this room. Gas and liquid always take the shape of their container. Alright, on to some other important vocab words. The phase changes, or changes between gas and solid. All those have different names, and it's important that we know all of them. So, looking at this picture, let's review them. Let's start at a solid. If a solid goes to a liquid, that's called melting. If a liquid goes to a solid, that's called freezing. If a solid becomes a gas, that's called sublimation. Sublimation is when a solid becomes a gas. When a gas becomes a solid, that's called deposition. Deposition is when gas is floating around and becomes solid. Gas is floating, comes together into a solid, that's called deposition. Alright, what about liquid to gas? Liquid to gas is called vaporization. Vaporization, or boiling, or evaporization are all words we use to describe liquid becoming a gas. Condensation is gas becoming a liquid. When gas becomes a liquid, that's called condensation. Condensation is when gas becomes a liquid. Alright, moving on. Here we go. Next part of the study guide, we have the atom. The atom is the smallest particle that can exist. And the atom is made up of subatomic particles. Those subatomic particles are called a proton, a neutron, and an electron. Let's take a closer look. So, this is what makes up an atom. An atom is made up of an electron, which is negative, and the electron is on the outside of the atom. Here are the electrons. The electrons on the outside. On the outside. Electrons are negative, and they are on the outside. Next up, we've got a proton. Alright, a proton is positive. A proton is positive, and it weighs 1 AMU. If we go into our picture of an atom here, the proton is here in the middle. Protons are in the nucleus in the middle of an atom. Electrons are on the outside and negative. Protons are positive and on the inside. And then finally, also in the nucleus is a neutron. A neutron is neutral. That means it does not have a plus. It does not have a minus. It's not positive. It's not negative. It is neutral. A neutron also weighs 1 AMU. A neutron is also at the center. We have our neutrons and our protons in the center of the atom, in the nucleus, and then we have the electrons on the outside. Going back to our handy-dandy study guide, the next one on the list is nucleus. The nucleus is the center of the atom, and it is made up of protons and neutrons. Alright, we'll get to isotopes in a moment. We're going to skip isotopes for now. We'll come back to it. Alright, so a couple of other things we need to go over, besides just talking about the atom, is talking about just what makes up matter. So we can organize matter into two different things. We can organize matter into pure substances or mixtures. A pure substance is matter that only has one type of particle. Only one type of particle. See, look at all these pictures. There's always one. One, 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 one. One, 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 one. There might be two stuck together here, but it's two everywhere. So all these count as one. Same here. There might be four things stuck together, but it's always the same thing repeating. That means there's only one type of something. A mixture is when matter is made up of two or more elements, all mixed together. So for example, look at this mixture. We have all these different colors mixed together. Look at these jelly beans. We have all these different things mixed together. It's a mixture. Alright, so in a pure substance, we can organize those even further. There's two types of pure substances. We have an element and we have a compound. An element is only one type of something. One atom of something. An element is made up of only one atom, one type of molecule. A compound is atoms pushed together. Compounds are pure matter, which are made up of two or more different atoms. So when we have a pure compound, we have the same compound over and over again. If we look at this picture of a compound, you can see we have more than one atom here pushed together. It looks like there's two or three different atoms pushed together, but because it's always the same one, we call it pure. Alright, we got two different types of mixtures. We've got a homogeneous mixture and a heterogeneous mixture. But let's give them some names that are a little easier to understand, okay? So, a homogeneous mixture is the same thing as a solution. So we have solutions and mechanical mixtures. Those are two types of mixtures. A solution is a homogeneous mix of two or more things, but you cannot see the difference between the two. A solution is so perfectly mixed it all looks the same. For example, apple juice. It just looks like juice. You don't see chunks of apples floating in the apple. You don't see pieces of sugar floating around, even though all those things are in apple juice. A solution is a perfect mix. A mechanical mixture is when you can see all the different parts of a mixture. You can see everything that's inside of it. For example, this pizza, you can see all the different parts. For example, this salad, you can see all the different parts. Alright, so on to talking about isotopes. So isotopes, those are atoms that have a different number of neutrons, but everything else is the same. So when we look at this picture here, I'm going to try and zoom in for us. Whoa, there we are, zoomed in. These three atoms are isotopes of each other. But in an isotope, only one thing changes, the number of neutrons. It's the only thing that changes. So proton stays the same. The proton is the same in all of these. the electron stays the same in all isotopes. The only thing that changes is the number of neutrons. We go from having 0 neutrons to 1 neutron to 2 neutrons. The neutrons are changing, and that makes these things isotopes. Alright, on to a couple of practice problems I've made for us. Alright, looking at this model, we know a couple of different things right off the bat. And I have all these practice problems on the study guide to help you guys learn, because I guarantee it's going to be a question like this on your final. So here we go. This is a Bohr model of an atom. So our first question here asks us how many electrons. Well, let's count. There is 1, 2, 3, 4, 5, 6 electrons. The electrons are on the outside, so there's 6 of them. Protons. Since this atom is neutral, that means electrons are equal to the protons. Since we know there's 6 electrons, that means there must be 6 protons. Electrons are equal to protons. Since there's 6 electrons, there are 6 protons. That's why we have 6. The atomic number. What's the atomic number? It doesn't say it on here. That's okay. The atomic number is always equal to the number of protons. So we know how many protons we have. We have 6. So since the atomic number is equal to protons, and we know that the protons are 6, then the atomic number has to be 6. So the atomic number is 6. All right, nice. Moving on. All right, the atomic mass. The atomic mass. Well, what's the atomic mass? The atomic mass is neutrons plus protons, and you have to add them together to get the atomic mass. But here's the thing. This is important. You guys will need to watch for this. If we give you an element and then give you a number right behind the element, this number here is the atomic mass. Look, it already tells us. So this says carbon 13. That 13 is the atomic mass. So that we write down for the atomic mass. If we want to know how many neutrons we have, we subtract the number of protons from the atomic number, and that gives us neutrons. All right, another practice problem. All right, here we go. How many protons do we have? Well, protons are positive, right? So they're anything with a plus. So we have 1, 2, 3, 4, 5, 6 protons in this atom. All right. What's the atomic number? Well, the atomic number is equal to electrons, and it's also equal to protons. So the atomic number is 6, because we have 6 protons. Name of the element. Name of the element. In order to find the element name, we'll have to look at our periodic table. Our periodic table looks like this. So we'll have to find something with 6. So it looks like, if I can show you guys here. All right, there we go. Carbon has this 6 on top. There we go. It has a 6 on top. Since carbon has this 6 on top, its atomic number is 6. That means this element is carbon. All right, electrons. There are 6 electrons because there are 6 protons. They're equal. The atomic weight is neutrons plus protons. So we add together the number of neutrons and the number of protons, and that gives us 14. On to the final example here. So for this example, remember the 23 after an element, that gives you the atomic mass. So 23 for sulfur 23 and 25 for sulfur 25. The number of protons, you'll have to look that up in the periodic table. In the periodic table, there's a 19 next to sulfur. So we know 19 is how many protons there are in sulfur. And even over here, there's 19 protons in sulfur. Alright guys, I hope this helped. Good luck studying, and you'll do great on the final exam.